Okay, this is Chapter 3, Section 2. It's the third video. So now we're going to look at some scenarios where we're doing the calculations, looking at exclusivity and independence basically. So let's say we have red marbles and green marbles in a bag and we're pulling them out randomly. And the red are marked 1 to 6 and the green are marked 1 to 4. What's our sampling space? Okay, well that's just like a paired type of deal, right? 1R. You can do 1R, R1, so red 1 or 1R for one red or red 1. It doesn't matter which way you do it essentially, it's up to you. Okay, so green and odd, well, that would be the 1 and the 3 green, right? There's only 2 of them and there's 10 total, correct? So that'd be 2 out of 10 is the probability essentially. Okay, so are R and G mutually exclusive? Can you be red and green at the same time? No, you cannot. You can be red or green, but you can't be red and green at the same time, right? So essentially using the rule, R and G equals 0, so therefore mutually exclusive. Because remember, there's only one rule for mutual exclusivity, is the and 0. That's it. Okay, let's go to the next one here. Are green and odd mutually exclusive? Well, no, it's 2. We just did that, correct? So since green and odd are equal to 2 out of 10, which is not 0, it's not mutually exclusive, right? Okay, there's only one rule for mutual exclusivity. Independence, however, right, there are 3 ways to prove it, right? So go back to independence, there are 3 ways you can prove it. You can prove it with either of the conditionals or the product, when you only need to do one of them, whichever one you have based on the information. Okay? So we go to here. Are R and G independent? Okay, so let's multiply those and figure it out here. So we'll do a math type, and I have the probability of red times the probability of green, and I get the reds are 6 of them, right? And there are 4 greens, right? So that's going to be 24 over 100, right? Then the question is what is the probability of red and green? Well, wait a minute, we just did that up above. That's 0, right? So those are not equal to each other, correct? So format color blue, right? So thus dependent. Okay? Thus R and G are dependent, right? That's the way you should probably put it. Which makes sense because if you draw 1, right, it's going to reduce the number in there, so it's going to so what happened before is going to depend on the next one essentially. So it's going to change the probability. So green and odd. So let's try this one here. So right, so green and odd. So we'll do green here, and we'll do odd here. Right. So the greens, there were 4 greens, right? There were 4 greens. The number of odds, if I look here, there's 1, 3, 5, 1, 3. So there are 5 odd balls, right? So that's 20 out of 100. So G and O. So green and odd, we already did. That was 2, correct? So we do here, fraction. That's 2 out of 10. Well, I'm pretty sure 20 out of 200 is the same as that, isn't it? So that means G and O are independent, essentially, right? So green and odd are independent, right? Okay, student problem. Let's say the events B is you check out a book, D is you check out a DVD, and these are the probabilities that are given. Justify the following. So determine the probability of B given D. Okay, so the probability of B given D equals, right, so we need the fraction. We'll put this on top. Okay, so we'll do and there. So and, oop, that's not the one I want. I want this one. Come on, fight me. All right, probability of D right there. Okay. All right, so now we'll use the numbers that are in the problem, essentially. So the numbers that are in the problem for and, so this is B and D, is 20, right? And then D is 30. Okay, so that's simply just 2/3, correct? Okay, so if we think about it, that is not equal to the probability of B, right, which in this case is 0.30, right? That's what we have right here. No, I'm sorry, 0.4. Wrong one, 0.4. Thus dependent, right? Right? They're not equal, so you did not prove independence, so thus dependent, correct? Okay, let's try the other one. What if I flip it around, right? So D given B. Well, let's take this here, and we'll just flip it around. So we want D given B, right? So D and B, and then put B here. So D given B, that's still going to be 0.20. It doesn't matter. When you flip that around, it doesn't matter. It's still 0.20. B is 0.40, right? So 0.40. So that's 2/4, right? So the probability of D is, let's see, 0.3, right? Well, 2/4 is a half, which is 0.5, which is still not equal to that, correct? So it's still dependent, isn't it? Okay. So are B and D independent? Let's try this a different way. Let's try to do it this way. How about we do, move it up to here, move it up to here. Probability of B, oops, wrong thing. Probability of B times the probability of D, right? So the B is 0.40, the D is 0.30. So 3 times 4, or 4 times 3 is 12, right? Okay. So we're using the third rule, which is the product rule for the independence, correct? So the question is, does that equal the probability of B and D? Well, the probability of B and D is given to us. That's 0.20, right? Well, I'm pretty sure that doesn't equal 0.20, so that's not equal to, correct? So if those are not equal, thus dependent. Okay? So, move this up, move this up. There are 3 ways to prove independence. We proved all 3 ways. Did we need to prove all 3 ways? No. No matter what we did, we've proved that it's not independent. There is some kind of dependence. This is what the dependent is. We have to do a little more work, but that's what it is nonetheless. Are B and D mutually exclusive? Okay. So, I'm going to cheat here and copy this. Copy. Right? And math type, paste. Right? Are B and D mutually exclusive? B and D is equal to 0.20. Which I'm pretty sure is not 0, thus not mutually exclusive. Right? Because there's only one rule for exclusivity, there are 3 rules for independence, right? Although we don't need to do all 3, we did all 3 essentially. Okay? All right, let's try one more scenario here. Okay, so you have a box that has 1, 2, 3, 4, and 5 for the blue, and 1, 2, and 3 for the red. So we'll switch it around the other way this time. Last time we did the number first and the letter second. We'll switch it up here, and now we'll do the letter first and then the number second. Not that it makes any difference, right? So R is the red drawn, so there's 8 things here, right? And 3 of them are red because it's 1, 2, and 3. Okay. The blue, there's 5 of them, right? So that's 5 out of 8. E is even, so that's 2, 2, and 4. So that's just 3 of them for the evens, correct? Okay, so the rest of these will involve some calculations, right? Okay, so we're going to do some calculations here. So let's shrink this down. Okay, so the conditional, this will be the probability of, let's do an equals here. The probability of E and B over the probability of B, right? Because that is the condition, right? The line means the condition. Let's make that blue, so that's the formula, right? Okay, and then we'll have fraction and fraction. All right. Oop, I didn't do the fraction though. There we go. There we go. All right, so B is 5 out of 8. We already have that. Okay, this one's obviously out of 8. So E and B. So what does that mean? We have to be blue and even. So that's only the B2 and the B4, isn't it? So that's only 2. Okay, so that looks like a probability of 2/5, right? Format, color, blue, or orange. Okay, that looks good. All right, well, what about the other way? Is that going to be the same thing? And as you probably guess, it's probably not. So let's switch it up a little bit here. So we're going to do B and E and E. Okay, because the condition now is E. So B and E and B are the same thing, 2/8. Well, the probability of an even number is 3, so this is 2/3. Not the same answer. It's the probability of being even given you're blue versus blue given you're even, right? That's two different subgroups, essentially, right? Okay. Are they mutually exclusive? Can you be red and blue at the same time? I'm going to guess no, right? So therefore, you are mutually exclusive, correct? All right, P of G. That's the next thing we want to know, all right? So P of G. G is the card where the drawn is greater than 3. Well, greater than 3 is only a 4 and a 5, right? So that means there are only 2 cards, or 2 marbles? Marbles. Red cards. Oh, they are cards. I'm sorry, cards this time. Right, so H is what? H is blue card numbered 1 and 4. Okay. Blue card numbered between 1 and 4. All right, 1, 2, 3, 4. So that's 4 cards, basically. Okay. All right. Good deal. All right, so what's our last question here? Are G and H independent? Okay, so to do some math here, right? So we have the probability of G times the probability of H, right? That's going to equal, well, the G was 2/8, right? And the H was 4/8. Okay, so that would make this blue. Format, color, blue. So that gives us a ratio of 8 64ths, right? Which is essentially 1/8 if you want to simplify it. Not a big deal. Whoops, that's not right. Okay, the question is this equal P of G and H? Right, so G and H. So that is G is the ones, or what? Numbers greater than 3, right? And between one, so that only would be the B4, wouldn't it? So that would be 1 out of 8. So in fact, I think we are actually correct here that these are equal, right? Thus independent, right? Do that and style text. Okay. All right. So we went through a bunch of scenarios for mutually exclusive and independence, right? So in either case, don't just state it based on your opinion. Show some actual math to prove it is or is not mutually exclusive, or is dependent or independent, whatever the case may be.